Alright, now it's recording. Now you can say what you want. But I think it only hears me. I don't know if it hears you.
Hello. I'm watching the video so I can hear
Oh, you could hear the students? Okay, so they can hear you. Okay, so today we're going to learn log shortcuts. First one. If we have log base b of b, that will equal 1. So what I'm going to do is I'm going to tell you the shortcut, and then I will explain the shortcut to you. All right, well, let's see. If I have, why does this make sense? If I have a log base 2 of 2, if I were to change this into exponential, it would be equals x. 2 to the x equals 2, right? Log, base, answer, exponent. Go back. I'll write it out. Remember, this is log, base, answer, equals exponent. So when you put this back, this is going to be 2 to what power equals 2? To the first. Well, what does that mean x has to equal? X has to equal 1. So that's what this shortcut is saying. Anytime your base and your argument are the same, it will simplify down to 1. Anytime your base and your argument are the same, it will simplify down to 1. All right, that's the first shortcut. Second shortcut. Log base b of b raised to the t will simplify down to t. So this is saying anytime your base of the log and the base of your argument are the same, it will always end up being the exponent on the argument. Let's show you. So let's say I have log base 2 of 2 to the third power equals x. So this is saying 2 to what power equals 2 to the third? Well, wouldn't x have to equal 3? Yeah. So again, this is saying anytime the base of your log is the same as the base of your argument, it will simplify down to the exponent on the argument. Next one. Sure. No, because you can't use your phone, but you'll...
No, yeah, I'm writing it down on my notes. I'm just taking the pictures so you can go.
Connor.
It's okay, I'll wait.
Alright. Let me just copy this down.
You good? Okay.
I'll have 2 pieces.
Okay, next one. Sure. Right here. What's wrong, Kelly?
How would it be 1?
For the first one? So I showed you in the example. So if anytime we have the log with a base as the same base as the argument, so the base of the log is the same as the argument, it will always simplify down to 1. An example would be log base 2 of 2 equals x. So this is saying, let's put it back into exponential. Remember, in exponential, it's log, base, answer equals exponent. So if we were to put this back into exponential, it would be 2 to the x power equals 2, which is really 2 to the first. Wouldn't x have to equal 1?
Yeah, but when you have like something where when the base and the other base are the same, you can just equal it to 1.
It will just always simplify down to 1, yeah?
Is number 2 like the same thing?
Number 2 is the same thing, but now the base has an exponent, so it's whatever the exponent is. The base of the argument has an exponent. All right, next one. Anybody still copying these?
I mean, I am, but like, I just have.
No.
It's fine. I'll wait.
All right. All right, I'm good.
You're good? Okay.
You sure you don't want to get out of your notes? Yeah. I'm gonna have to watch videos anyway. I'm gonna forget this.
Okay, so this is saying, let's say I have a base raised to a log power, so log base b of t. So now I have a base and it's raised to a log power, but the base of the log is the same as the base of the exponential. That's going to simplify down to t. Oh, wait, I should have given you, well, that's okay.
Is this like a new problem? Like a...
Yeah, this is a new shortcut.
Okay.
And actually, let me give you the rest. The next one is going to be very similar to this, but what I'm going to do is I'm going to make it e and ln instead. So this is saying if I have e raised to the ln of t, that will equal t. Okay, I'm going to go back now and explain this to you, even though these two are very similar. One just uses log, the other one uses ln. Yeah. Yes. So let's go back to number 3. Let's say I have 2 raised to the log base 2 of 8. So the key here was the base of my exponential is the same as the base of the log, the base of the log in the exponent. See how it was 2 as the base of my exponential, but 2 as the base of the log 2 in my exponent? That's the key here. So this is saying if I were to simplify this down, it should be 8. That's what the shortcut is telling me. That if I saw this, I could just say the answer is 8. Well, let's do it the longer way. The longer way says, let's simplify the log here in the exponent. Well, this log exponent is saying 2 to what power gives me 8? And you guys tell me, 2 to what power gives me 8? 3. So this whole log is actually 3. And what's 2 to the third power? 8. All right, so do you see how that shortcut works? It allows us just to do things a little bit quicker. All right, there's one more that we have to know. And the last shortcut is going to be log base b of 1 equals 0.
Wait, what's the...
Did we do number 4?
Number 4 was the ln. This is the same thing as number 3. It's just ln instead of log. Because remember, ln is log base e. So this is the same as saying e to the log base e of t. See how it's the same thing as the other one? Equals t. All right, number 5. Let me explain this to you. Let's say I have a log base 2 of 1 equals x. Well, isn't this saying 2 to the x power equals 1? Well, what exponent makes everything 1? 0. So this is saying x has to equal 0. So no matter what base you have, if your argument is 1, it will always simplify down to 0. Sure. Like here? You're welcome. Okay, let's do some problems. So I want us to evaluate and the first one's going to be 2 raised to the log base 2 of 8. That's what I just did. Well, isn't this a shortcut? Isn't this the same as b to the log base b of t? Well, b to raised to the log base b of t equals t. So what's this one? 8. Okay, next one. Okay, let's say I have e raised to the 2 times ln of 10 plus ln of 3.
Wow, you just took it from like 0 to 100.
No, I really didn't though. Let's just simplify that exponent. We're going to simplify that exponent. So the first thing I'm going to do is I'm going to really condense the exponent. So I'm going to pull that 2 in the front. Can I put it as an exponent on the 10?
Yeah.
Okay, so now this is going to be e to the ln of 10 squared, which is what? 100 plus the ln of 3. Are we good with that so far? Yep, so now I'm going to condense this even further to be just 1 log. So now this is going to be e, and now I could pull out 1 ln, and what can I do with the arguments if I'm condensing, since it's addition? We can multiply them. So this is 100 times 3. So this is e to the ln of 300. Well, guys, this is one of the shortcuts. E to the ln of t equals t. So what's our answer?
300.
300. Not bad, right? Can I keep going?
Yes.
So I have log base 2 of log base 3 of 81. Okay, well, didn't we just learn one of the shortcuts is if I have log base b of b to the t simplifies down to t?
Yeah.
I can't use that right now, but looking inside my parentheses, I can't use that right now because the base is 3 and my argument base is 81. But can I make 81 into a base of 3?
Yes.
We sure can, so let's do that. So we're going to say log base 3 of 3 to what power? 4. Good. Okay, well now inside my parentheses, doesn't that follow that shortcut?
Yeah.
So what does the whole parenthesis simplify down to? 4. So now I have log base 2 of 4. Can I change this again to look like that shortcut?
Yeah.
We absolutely can. So now we can change this into log base 2 of 2 to the
2.
second. So what's my answer? 2. Anybody still copying? Okay. Ew, that's gross. Why are kids so gross? All right, so this is log base 2 of 8 times log base 2 of 1/4. So, can you talk? No, I cannot talk. Okay, can I change these to make it look like some shortcuts?
Yes.
I think I can. I can change the first one and to make this log base 2 of 2 to the 3rd power. So this is going to be log base b of b to the t equals t. So what does this whole side simplify down to?
3.
3. All right, let's keep going. Now on this side, it's going to be a little bit, but I can still manipulate it. So this is going to be log base 2 of 4 to the negative 1st power. So the first thing I did was change the fraction into a whole number with a negative exponent. Can I make 4 into a base of 2? We can. This is going to be log base 2 of 2 to the negative 2nd. And now, can I use the shortcut on here?
Yeah.
We can. So this is going to be 3 times what? Negative 2, which is negative 6. Okay, I want you guys to try this one on your own. I'll give you a minute to finish copying.
It's just all we're learning today.
Yeah, this is it. I'm not sure. Not too many more. Okay, we ready? You guys are trying this one. Log base 2 of 8 plus log base 3 of 1/9.
I know you put
I'm actually going to also have you guys do this one by yourself. Log base 2 of 8 plus log base 2 of 1/8.
Have you used all three of them yet? All three shortcuts?
I'm not sure. No, we haven't used all of them.
Was the first one?
Yeah. What'd you say? 1, right? Yeah.
Yeah, this actually.
Okay, so for the first problem, I'm going to have log base 2 of 2 to the 3rd, which tells me this will simplify down to 3. And then on this one, I'm going to have log base 3 of 9 to the negative 1st power. Well, then I'm going to have log base 3 of 3 to the negative 2nd power, which simplifies down to negative 2. And then I'll have 3 plus a negative 2. What's 3 plus negative 2? 1. For number 6, I can condense it into 1 log. How come for number 6 I'm able to condense it down to 1 log, but for number 5 I wasn't able to condense it down to 1 log?
Different bases.
Good. In number 5 they have different bases, but in number 6 they have the same bases. So I can absolutely condense this down to 1 log. So this is going to be log base 2. And then what am I going to do with the arguments? Multiply them. 8 times 1/8. What's 8 times 1/8? 1. Well, doesn't this follow another shortcut? It is. Log base b of 1 will always be 0. Did anybody did anybody simplify the 2 logs and then add them together? Yeah, if you did that, you got the same answer. So let's do it that way. So if you did log base 2 of 8 plus log base 2 of 1/8, you would say log base 2 of 2 to the 3rd power, which would give us 3. And then here you'd have log base 2 of 8 to the negative 1st. So this is going to be log base 2 of 2 to the negative 3rd. And then we'd be left with 3 plus a negative 3, which is 0. I don't care which way you do it. Okay, so now I'm going to step it up and I'm going to make it a little bit challenging here. What number was that? 6? All right, number 7. So I want us to solve. And I have log base 7 of log base 3 of x equals 0. There's nothing that's going to help me here. There's no shortcut here, right? Can I manipulate an x into a base of 3? No, we can't. All right, so I can't use any shortcuts. But what I am going to do is I'm going to treat this like a log problem that I'm going to change back into exponential. What do I mean? I'm going to say the outside log is my log, so log base, my parentheses is my exponent. So I'm going to treat that as my argument equals, oh, sorry, not my exponent. My parentheses is my answer. So I'm going to treat this as my answer equals the exponent. All right, so now what I'm going to do is I'm going to change to exponential. I'll write this down. Change. Okay, what do I mean by change to exponential? I mean, I'm going to go and I'm going to take the base of the log, which is 7. I'm going to raise it to the exponent. What's the exponent? Nobody knows what's the exponent. No. 0. I'm going to raise it to the exponent, and that's going to equal the answer. What's the answer? Log base 3 of x. What's anything to the 0 power? 1. So now I have 1 equals log base 3 of x. So I'm going to change into exponential again. So remember, it's log base answer equals exponent. What's my base this time? 3. What's my exponent?
1.
And what's the answer? No.
0.
X, right? And what's 3 to the first power?
3.
So x is equal to 3. We're done. Okay, 3 more problems. Okay, so given log of 2 equals a, log of 3 equals b, and log of 5 equals c. So the first thing I want to do is I want to find log of 15 in terms of A, B, and or C. Okay, so what does this mean? I have log 15. Well, I know log 2 is A, log 3 is B, log 5 is C. Well, log 15 is not A, B, or C. But can I change 15? Can I change 15 into 3 times 5? And then I could expand this into log of 3 plus log of 5. And what is log of 3 equal to? B. And what's log of 5 equal to? C. So now have I expressed log 15 in terms of A, B, and or C? Yeah. Can I keep going to the next problem? Okay, we're using the same given information. And I have log of 1 over 30 expressed in terms of A, B, and or C. Ethan,
Yeah.
stay with me. Almost done. One more problem after this. Okay, so I'm going to change this into the log of 1 plus the log, oh, sorry, not plus, minus the log of 30. I expanded it. Is everybody okay with that? What base do these logs have even though they're not there? When it's not written, what base is it? Who remembers? 10. So guys, this first part's a shortcut. What's log base anything if the argument is 1? 0. Very good, Kelly. So this is 0. So now I just have 0 minus, and now I have 30. Can I split 30 up into multiples of 2, 3, and 5? I think so. Can I have 2 times 5 times 3? Doesn't that equal 30? So what am I going to do with this argument, 2 times 5 times 3? What should I do with that?
Make them all into logs.
Good, and put what between them?
Addition.
Yeah. So now I have log base 2 plus log base 5 plus log base, log of 2 plus log of 5 plus log of 3. Is it important that I put parentheses around this?
Yeah.
Yeah, because we're subtracting this whole quantity, not just one part of it. So now we have 0 minus, what's log of 2? A. What's log of 5? What's log of 3? I could written the A, B, and C in any order. Addition's commutative. It doesn't matter. So now I have 0 minus this whole thing. Now you have a choice. You could leave it as negative A plus C plus B, or you can distribute it in and get negative A minus C minus B. Either answer is good. All right.
Can we go up a little bit for a second?
Sure. Like here? You're welcome. Okay, so I'm going to split this log. I'm going to make this 5 times 1,000. And then I can make this into log of 5 plus log of 1,000. Log of 1,000 is actually a shortcut. Why? How do I make log of 1,000 into a shortcut?
You can make it have exponent.
Make it to 10 and the base up there is 1.
Yep, our log has a base of 10, and then I can make 1,000 into a base of 10 raised to what power?
10. 2.
3, right? 3 zeros. So what does this simplify down to?
3.
3. And then what about log of 5? What's log of 5?
C.
C. So we're just left with C plus 3. We're done.
Are you allowed to have numbers in it though?
You could have numbers, yeah, as long as there's no more logs.